So let me share the screen. Is my voice audible?
Yes,
Yes,
sir.
sir.
Just a minute. Is the screen visible?
Yes, sir.
Okay. Okay, today we'll see some of the basic concepts of the electrical actuators. So before going to the actuators, let us see what are the transducers. A transducer is a device which will convert one form of the energy into another form of energy. So transducers, you can say sensors and actuators are some kind of transducers. So here a sensor is a device that can convert mechanical energy into electrical energy. We use sensors to detect some physical phenomena, to sense some physical phenomena. So wherever we want to sense some physical quantity, so that energy we will read and convert to electrical signal, so which can be fed to a computer for meaningful result. So here we can see measurement system. So this is the basic scheme of the measurement system generally we encounter in any industrial application or robotic applications. So first there is a physical phenomena, which we want to sense through a sensor. So after converting the physical quantity to a electrical signal, that signal may have different kind of noises. So that has to be conditioned so that we can read it properly. So generally these signals are kind of analog continuous signals, so that has to be sampled. Sampling means like at a particular time period we will be taking the analog signal readings, so that is passed to the analog to digital conversion. So analog signal is a continuous signal with respect to time. That means for any given time there exists a quantity which can be represented in terms of some numerical quantity. For a digital signal, so it is not a continuous signal. So there exist values only at particular given times. So that is a basic difference between analog to digital conversion. So we can give example for analog signal like a some voltage flowing in a current in a wire with respect to time. So at any given point of time we can get the signal. So here analog signal is converted to digital signal, then that is fed to a computer. So through some interface like some communication channel, or it can be a analog to digital reading device, or it can be communicated through RS-232, RS-485, or USB, or different kinds of interfaces. So now we have seen the sensor part. So sensors and actuators basically belong to transducers category. So what sensors are doing? Sensors are sensing some physical quantity and converting to some electrical energy. So here actuators are also kind of transducers which are used to produce motion or action, such as linear motion or angular motion. So sensors are sensing and giving the readings in terms of electrical quantities which can be read. But here actuators are for inducing some motion in any mechanism, or in any machine, or any robotic applications. So electrical actuators and sensors both are transducers that convert electrical energy into mechanical energy. Here it is just opposite to a sensor. So here actuators, what they are doing, converting electrical energy into mechanical energy, where this energy can be used to move a link, or to rotate something, to move, for example, movement of conveyor belt, or mixing up something. So like that we can make use of these electrical motors. So electrical motors are very prominent because they are always required in several robotic application, industrial application. So there are different kinds of these electrical actuators which can be classified as DC motors, servo motors, and stepper motors. So in DC motors also there are like brushed DC motors and brushless DC motors. So here we will see the brief on working principle. So most of the motors work on electrical principle of induction. What is it? So whenever a current carrying whenever a conductor is carrying a current, or current is flowing in a conductor, so it produces a magnetic field. So through the process of induction. So whenever this current is flowing, so due to this magnetic field, and when this is placed in another magnetic field, so magnetic field will have two poles, south pole and north pole. So here now the conductor is placed in a magnetic field. So due to this, so south pole and south pole will repel, or north and south will attract. Due to these repulsion and attraction forces, this current carrying conductor will experience a torque which will result in motion of the conductor. So this principle is used to have a meaningful motion in the form of a electrical motor. So in the next slide we will see here you can see in the first image that there are two fields. The inner one is the rotor, outer one is the stator. That means the inner one is the rotating element and the outer one is the static part. So generally for small motors, the outer winding which is producing a magnetic field can also be a permanent magnet. Here we are seeing in the first picture, it is a motor winding. So whenever the winding is energized, it is going to produce a magnetic field. So here we can see that it is marked with N. Here outer one, outer winding, that is the stator winding, N and S. So here it is producing north and south pole, and the current carrying conductors in the on the rotor also producing N and S. So here we can see that N and N are going to attract repel each other. So and S and N are going to attract. So due to this winding will subject it to the anti-clockwise rotation. So here in the second image we can see that there are two permanent magnets. So that field is always fixed. There are north pole and south pole, and the current conductor we can see that it is going through in between the magnetic field, and again it is reversed and coming out. So due to this arrangement, so here this is just a brief schematic of the winding, but in practical motor there are several such type of winding wires on the armature, so which will result in torque with a continuous torque. So when this coil is mounted on a spinning shaft, due to these forces generated, that due to the special arrangement of this coil, that will produce torque which will rotate the motor. Now suppose in this case, say in the first image, say now S is going to attract N. Suppose in that case, if the rotor rotates by say 120 degree anti-clockwise, now S and N will align. S and N will align here on the vertical axis. So at this condition, what happens? This motor that is the minimum possible distance between these two poles. Now the motor stops rotating if we are not going to change the south and north poles on the rotor winding. So in that case, what we need to do is, whenever they are coming near, after they achieve the shortest distance, we should reverse the flow of current in the winding, so that again they will start repulsion or attraction. So now what happens, the S is going to come down here. So when the current is reversed, the south pole becomes north pole on the rotor winding. So when it becomes north pole, again it is going to repel, so it will continue the motion. So in this way, the continuous motion in the electrical actuator can be achieved. So this action of reversing the electrical field in the motor winding is done through a mechanical arrangement in the motor. Those are called brushes. Those are simply nothing but two carbon coated contacts. So due to the rotation of the armature winding, they automatically will result in shifting of the in reversal of the electric field. So here in the second image we can see that the one coil is shown. So that polarity, we can see that the top one is the plus and the bottom one is minus. So now what happens, assume that there are two contacts here and here, plus and minus, which are supplying the electrical field to the coil. So now what happens, when this rotates by 180 degree, the lead which is in contact with the positive terminal, that is going to come towards the negative terminal. The negative terminal goes to positive terminal. So in this way, the electrical field is reversed and a continuous torque can be produced. So the now we understand that this continuous torque is achieved through the action of commutation. So that commutation is nothing but the reversal of the electrical field in an electrical actuator to produce a continuous torque. So this commutation is done through mechanical brushes in most of the DC motor. So what happens due to this contact, the contact between the armature winding and the brushes, so due to the continuous rotation, these brushes are going to worn out with time. So this is one of the advantage, and also sorry, this is one of the disadvantage. And the other disadvantage is that due to this sliding contact, and through that contact only electrical field is passed from the brushes to the armature winding. So the some sparks would be generating, and it will result in heat and loss of energy. So these two are the disadvantages of the DC motor. To achieve, to overcome this in with present days technologies, so there comes a concept of BLDC motor, that is brushless DC motor. So here the what we need to do for continuous rotation of the motor, that we need to reversal the magnetic field direction in the armature winding. So here whatever we have seen, that is basically done through mechanical commutation. So in case of BLDC motor, what happens is that, so there is electronics associated with the motor. So here the coil is permanently connected to the one lead is permanently connected to the positive, and one lead permanently connected to negative, and there are no slipping or sliding contacts in between. So as they are permanently connected, that electrical field cannot be reversed in through mechanical process, and so the electronics associated with the motor itself will reversal the electrical field. So this is called electronic commutation. So this is done through sensing of the armature winding position, and at that speed it is going to reverse the electrical field based on the position of the rotor. Then that will result in continuous motion of the motor. So this is the basic difference between BLDC motor and normal DC motor. So here we will also see that there is an effect called blowback or back voltage. What happens is what we have learned, the basic principle is that whenever current carrying conductor produces a magnetic field, in the opposite is also a true opposite phenomena also true. Whenever a conductor moves in an electrical field, it can produce a current, like the principle of generator. What happens in generator? So generator mechanical energy is given as an input, and it produces electrical energy as output. So that is just like a motor. So in motor we are giving the electrical energy and getting out the mechanical energy as output. But in generator, what happens is that it is just opposite phenomena, and the construction wise they are very much similar. So here also, so in the motor itself, when we rotate the armature without producing electricity, without supplying electricity to the armature, so what happens due to the existing magnetic field of the stator, so it will it will induce a current in the wire. So that current flows into the electronics of the motor, and that may result in the damage of the electronics. So this EMF, which is produced due to the motion of the armature and the presence of the magnetic field of the stator, is known as the back voltage, because it is flowing in a back direction. So what is our intention of the motor is that we will be supplying electrical energy and requiring mechanical energy as output. But sometimes what happens is that if the motor is connected to some mechanism or some vehicle or some machine, so due to the motion of some other elements, the motor is driven, and when the electrical energy is not supplied, so the motor itself will be acting like a generator and producing some voltage. So here that may result in damage of the motor electronics. So this is stopped by a simple use of a diode. So diode is a electronic device which will allow passage of electricity in only one direction. So when we place a diode in the line of in series with the armature winding, what happens is that whenever we want to supply the current from the input end, it will forward that electrical energy. Whenever the motor produces the electrical energy, it will block so that it will not reach the electronics and cause damage. So this is called blowback effect, or back voltage, or back EMF. So this back EMF also, whenever we rotate the motor, always not only when we are supplying the energy, but even in a normal operation also, it keeps on generating some back EMF. So what happens when we are increasing the speed of the motor, the back EMF is also will be continuously increasing. So when this back EMF gets saturated, then motor, that poses a limitation to the motor, that for a particular motor we cannot achieve we cannot achieve beyond certain range of the maximum speed. So this back EMF in case of BLDC motors also used for sensing the rotor position. So here in the electrical actuators, we will be seeing in detail about DC motor. So a DC motor, as I have discussed, will have two terminals for supplying the electrical energy, that is the positive and negative terminals. So DC means the direct current. So direct current means, as you must be aware, that the voltage level will be always in positive or negative, it will not be varying. Alternative current means it will be varying like a sine wave. First it will be positive, then slowly reduces to zero, again it will becomes negative. So here always reversal of polarity keeps on happening. So there are different motors which will work on DC and AC power. So we will be mostly discussing the DC motors only. So in robotics, we'll use mostly DC and BLDC motors, and AC motors generally they use in industries for heavy load applications. So whenever we supply the electric energy, motor spins in one direction, and when the plus and minus polarities are reversed, so the motor will rotate in opposite direction. So in this way, by switching the polarity, we can change the direction of the motor. So to do all this, like whenever we want to rotate motor at certain speed, suddenly increase or decrease, or position or hold that particular position, or reverse the motion. So for doing all these, we need the electronics like DC motor drive and a microcontroller. So in the next class, we'll see how we can make use of microcontrollers for controlling different motors, and also how to read data from different sensors. So here what we need for controlling of the DC motor is a DC motor driver along with the microcontroller. So these direct control motors are popular because they can achieve very high speed So the speed is generally measured in terms of RPM, that means number of revolutions per minute. They are very simple to operate, these DC motors. So what we all need to do is to control the voltage to vary the speed. So in motor we can say that voltage is proportional to the speed, and the current is proportional to the torque of the motor. So here if you want to change the speed of DC motor, we will just need to increase or decrease the voltage. So when the voltage is increased, so, that results in increasing the speed of the motor, and when the amount of current is large, the torque supplied by the motor is also large. So and also their starting torque is very large. So in cases where the starting torque is required, the DC motors are used for those applications. Nowadays we see a lot of electric vehicles. All of them mostly comes with a BLDC motor. BLDC is also, as we have discussed, is a special type of DC motor. So even for two-wheelers, these DC motors are used as a traction device. So here we can see the practical construction of the DC motor. In the first image, you can see the bottom one is the stator part, and the top one is the rotor part. So here we can see that there are some windings on the stator as well as rotor. So what happens? The stator has to stator coils are used to produce a magnetic field, and the rotor coils are also when they are carrying current, they also produce magnetic fields. By properly managing the magnetic field directions, we will be continuously getting the torque, which will result in the spinning of the shaft. So here there will be several coils arranged in a particular manner depending on the number of poles on the armature. So poles, number of poles means in the second image you can see that there is one north pole on the top and one south pole in the bottom. So what happens when we have only one pole pair like this? So the torque which we will be getting will be intermittent. So if you want to get a smooth and continuous torque and smooth operation of the motor, what we need is more number of these magnetic fields, magnetic pole pairs. Now in a practical scenario, like there will be some 8 pole motor, 6 pole motor, like that. So number of north and south pole pairs will be more, and they are all distributed in all the in 360 degree of the stator. So like that we can see in the practical scenario there are several coils to improve the magnetic field and torque capability of the motor. So we can we'll see the classification of the DC motors based on the field windings. So what we have seen is that for a normal motors, for a small applications, the stator will consist of a permanent magnet. So the permanent magnet, they are magnetized. They are produced magnetized. Once they are magnetized, until we choose some destruction process, they will remain to hold the magnetic field. So how what can destroy a permanent magnet? Say they are subjected to very strong magnetic fields, or when the temperature is increased, the permanent magnet can be demagnetized. Other than that, when we are operating in a normal room temperature, a permanent magnet will continue to behave with the desired magnetic field behavior. So, but in case of large motors, these DC motors, the magnetic field on the stator is produced through a winding. So here we can see that here, and the left one is the armature winding that is going to produce a field winding, and the right one is armature winding. So here these are not connected at all, and two voltage sources are energizing both the coils. So in this way, when the construction is like this, it is called separately excited machines. Means the field is excited separately, and the armature is excited separately from different sources. So, and the other one is the shunt machine. In this case, what happens? The voltage source is same, but the field winding and the armature winding are connected parallel to each other. So, as the voltage source is same and they are called and they are connected in parallel, this configuration is called shunting. So and the next classification is the series machine. In this case, what happens, the still the voltage source is single, but the winding connections are in series to each other. The armature and the field windings are connected to series each other. So depending on these types of windings, there are some disadvantages and advantages, and motor speed torque characteristics can also vary based on the construction of the motors. So depending on application, we can choose what kind of this motor shunt machine is required or series machine is required. So that can be decided. So the series field winding is composed of a smaller number of turns than the shunt field winding. So due to this, what happens? So that they are carrying equal amount of current. The current in the shunt field is equal to the supply voltage divided by the field resistance. Hence, the series field winding carries a much larger current than the shunt winding. So the next classification is the compound machines. So we have seen a series and shunt machines, where in shunt the windings are connected parallelly, and in series they are connected in series. So when we use both of these in a single construction, that is called a compound DC motor. So now in the next part we are seeing how we can control the DC motors. So what happens, as we have discussed, the voltage is proportional to the speed and the current is proportional to the torque, right? Now if you want to control the speed, what we need to do, we need to anyhow change the voltage. So that voltage can be changed by adding a resistance in the first case. So here in the armature winding, we have seen that there is a variable resistance. So by varying the resistance, the voltage across this armature winding will change. So due to that, the speed can be altered. So if you use a larger resistance, the voltage is going to drop, and the current is going to decrease. Then the magnetic field intensity also will reduce, which will result in lower speeds, and decreasing the resistance will increase the speed of the motor. In the second method, here the voltage is changed directly. So now the source itself, there is a variable voltage, and whatever resistance in the series, that is fixed in this case. So that resistance is due to the coil itself. So whenever any conductor is carrying current, it will have some resistance that is defined as resistance is rho L by A. Rho is the resistivity, L is the length of conductor, and A is the cross section of the area. So sometimes the windings, though they are in the compact form, if you just open the winding, the wire length will be quite huge. So that will have some resistance that is shown here as RA, and in left side it is called RF, that is a field resistance, and armature winding resistance. So the first method we have seen that voltage is changed by varying the resistance. So when the voltage is changed, the speed is adjusted, and here at the source itself the voltage is varied. In the first case, the source is fixed, that is Vt, and due to change of resistance, the source voltage what is supplied to the armature is changing, and here the source itself is changed. In the third case, the armature voltage and resistance are kept constant, but the field winding is changed. Field winding voltage supply voltage is changed. Due to this, the magnetic field surrounding the armature is going to vary. In case of stronger magnetic field, the motor can produce higher speeds and greater torque. But in case of weaker voltage, as the magnetic field is weak, automatically the speed also will decrease. So these are the different methods where we can control DC motors. Now, now the question comes practically how will we vary the speed? Suppose we are saying we have to change the voltage, but how we can practically change the voltage? If you take suppose a battery, it will have a fixed voltage. Say if you take 12 volt lead acid battery or lithium ion battery, so mostly the voltage will be constant. So how we can change the rotation or speed of the motor? So that answer is that we can use pulse width modulation to change the voltage of the source. So PWM is nothing but a on and off signal. So what happens? So this is just kind of a discrete signal, not kind of it can be a signal or it can be actually a voltage source variation to decrease or increase voltage. So here. So PWM pulse width, we are saying it is a pulse width modulation because say we are going to use some kind of electrical switching to have a on and off behavior of the voltage source or a signal source. Now this PWM is characterized by the on percentage time on. Say if I say 50% duty cycle, that means 50% of the time it is on and 50% of the time it is off. So the high pulse which you can see, that signifies the on time, and the low pulse, that is 0 level generally, that is off time. So now suppose if I am taking a 5 volt source and applying this PWM on that source with 50% duty cycle, what happens? So the 5 volt is supplied 50% of the time and it is switched off 50% of the time. Effectively, the averaging of this voltage level falls to 2.5 volt. So in the same way, 10% duty cycle will further reduce the voltage level. Like this, by continuously switching on and off, we can change the effective voltage, average voltage. So here you can see in the second it is 75% duty cycle. That means 75% of the time it is on and 25% time is off. So the time period is defined in this case as the time taken by one cycle, that is one on and one off time. So if I say it is a 50 hertz PWM signal, that means the in 1 second this on and off cycles are completed 50 times. So generally for practical applications, for any giving any signal to the devices, we will use 50 hertz 50 hertz signal, or sometime if we require a higher control of the devices, we will use PWM in terms of kilohertz, like 5 kilohertz, 10 kilohertz. So that frequency is defined as the number of cycles executed in a single in 1 second. So in each cycle there is off time and on time. So the amount of time it is on is called on time, and amount of the time it is off, it is called off time. So one on and one off total constitutes one cycle. So here, by applying this on and off principle, we can change effectively the source voltage. So suppose if it is 100% off, that means the voltage supplied is 0. When it is 100% on, the voltage supplied is equivalent to the source voltage. So when the 50% duty cycle is applied, so the voltage will become 50% of the input voltage. So respectively, like you can choose any percent of the duty cycle. So for doing all these, we need some kind of microcontrollers. So I'm just checking whether the link is active and there is no problem. So everybody is following, right?
Yes, sir.
Anybody can please reply if you are able to follow me.
Yes, sir.
Yes, sir.
Hello.
Yes, sir.
Okay, I'm not getting any feedback from you whether you are able to audible or not. So I am assuming as my connection is okay. I'm just continuing the lecture.
Yes, sir.
Yes, sir.
Okay. So have you understood the pulse width modulation principle?
Yes, sir.
Yes, sir.
Okay.
Yes.
Yes.
Okay. So we'll be moving on to other kind of motors, that is servo motor and stepper motor. So servo motor is also a kind of small device which consists of a motor, a speed sensing unit, and associated electronics to control the speed or position of the motor. So formally the definition is that a servo motor is a small device which has an output shaft which position of the coded signal. So so here you can see the construction of a basic servo motor. So we have seen till now the basic DC motor where it is having two windings and two leads for supply of the energy to it so that it can rotate. But here the servo motor will have an additional components, additional elements with that. So servo motor, the basic principle is that, say, whenever if we give signal to it, the voltage is always applied and we will be sending signal to it to hold particular position or to continue rotation at particular speed. So the commands are sent in a periodic manner to communicate the desired position and speed. So I'll just go to the block diagram to show you what is a servo motor is actually. So so here we can see that there is a microcontroller to send the command, and the three blocks: servo control unit, motor, and position part. These three constitutes in a single package is called a servo motor. So here along the motor there are two additional elements, that is the position part and servo controller unit. So what say for a normal DC motor, whenever we supply voltage, it will rotate, and when the supply is cut off, it will stop. But if you want to control the position precisely, then we should have our own controller, which can maintain the position of the motor at a particular position. But servo motors will have an advantage in terms of maintaining a position. We don't need to build any separate electronics for that. It will have inbuilt electronics that is shown in servo control unit and a position pod. So here we can see that this is just a cut section of a normal RC servo motor, where you can see there is a DC motor, and there are associated gearbox and an electrical control unit, that is generally kind of a small dedicated microcontroller, and a position feedback sensor. So now suppose we are communicating that it should hold its shaft at a 90-degree position. So now the signal is read by the desired position is read by the control circuit, and it will take feedback from the position sensor. Say we are asking to maintain at 90-degree, but if it is say at 0-degree, so now due to the difference of the desired and actual position, so the controller will give some voltage input to the motor, which will which will result in the rotation of the shaft, and whenever it reaches 90-degree, the position sensor is sensed, and it will communicate again to the control unit, and control unit will automatically cut off the voltage so that the motor will stop at 90-degree. Now when we are continuously communicating to the servo controller that we need to maintain at 90-degree, even when the external disturbances are present. Suppose at 90-degree it reached and it stopped, but due to some external torque, suppose the shaft is moved from 90 to 95-degree, again the controller will automatically bring the shaft position back to 90-degree. So in this way, so whenever we want to control anything, so here our we don't need to take too much computational or controller into our hand. So the inbuilt controller will itself will try to maintain the position and speed as set by the user. So this is another view of the actuator. So So here we can see that the same thing. The servo controller will have generally three leads, that is a power supply, positive and ground, and one is the signal. So the signal generally that is a PWM signal. So by just sending a PWM signal, we will be communicating to the servo controller like what desired speed and position is. So this block diagram we have seen. So here now we can understand better after seeing the construction of the motor. Say now, say the microcontroller is commanding the position that is communicated to the servo controller unit. Now when the desired position and the actual position is taken from the position port, that is a potentiometer, port is a potentiometer, which will read the position of the shaft. So when there is a difference between these two, position command and position feedback, so there the servo controller unit sends some electrical energy to the motor, that is current. Now in turn motor will start rotating, and the position pod again continuously takes the rotational information and sends feedback to the control unit. Whenever these two matches, desired and the actual position, so the controller output becomes nearly zero and motor stops. So the application of the servo motors include computers, toys, CD, DVD players. So in robotics application also for different say mobile robotics, so for rotating the wheels, or in case of leg robotics, so for each leg may constitute multiple motors. So, in case of leg robotics, these servo motors are very much useful because they are not just continuous rotating links. We just need to move the link from certain angle to certain angle repeatedly. So here, as the servo motors will have its own electronics, we don't need to worry more about how to maintain the position. We just need to communicate to the motor which position we want time to time, so that controller will itself will take action and maintain the position and speed of the motor accordingly. And it is also used in industries like conveyor belts, like product labeling, where the conveyor belt has to move sometimes continuously, sometimes discretely, where it will move one step and stop, move one step and stop, where different activities are carried out like labeling, bottling, and packaging. So it can also be seen in a very small devices like cameras, even including cell phone also. We can see that there are very small motors which will just move the lens forward or backward just to make the focus right. So these are all called servo actuators, servo motors, and the mechanism is called servo mechanism. Mechanism of controlling the particular maintaining the speed and position is called servo mechanism. So the advantage of servo motor includes high output power to relative to the motor size, and resonance vibration free operation, because the motor is constructed and the controller is also inbuilt. It can avoid resonance and vibration. So often the efficiency is high, and high speed motions are possible. So in the next category, we will be seeing the stepper motor. So a servo motor is including a DC motor, but here we are going to see a new construction of the motor. In stepper motor, the name comes from its construction and the operating principle. So this stepper motor moves in kind of steps. Suppose say now we are printing something in a day-to-day life. So where the paper moves in steps. Say each line, whenever it is printed, it will move one line feed like this. So for this kind of application, these stepper motors are very much useful. So here in stepper motors, again stator and rotors are present. So on the stator there are magnetic poles, and the rotor also there are magnetic poles. So in normal DC motor, what we have seen is that there are windings or permanent magnets. By changing the by energizing the winding and by continuously changing the field direction, we are getting the continuous motion from the motor. So that is also done through attraction and repulsion of the magnetic poles. Here also it is same, but the construction and operation is different. What happens on the rotor, there is a that is a here for simplicity, let us assume that this is a permanent magnet having north and south pole. So on the stator also there are magnetic poles north and south. So on the stator we can see that there are two poles which are shown in one pair is shown in red and blue, which is active, and the other one marked with two, south and north pole, those are inactive. So here the construction is like the magnets on the stator can be switched on and off, so that we can change the motion of the rotor. So now say now the coil 1 is energized, so the rotor aligned to the magnetic field of the winding 1, and when the winding 1 is turned off and winding 2 is turned on, the rotor again rotates to 90 degree. So we can observe that through some animation here. See how the see by just continuously changing the activation of the coils. So here two coils are shown for simplicity. So when the coil 1 is activated, the rotor becomes vertical. When coil 2 is activated, rotor becomes horizontal. By continuously switching the magnetic by just activating and deactivating the coils, we can cause the rotation of the shaft in terms of steps. So now when these coils are switched separately, so the motor is rotating in terms of 90-degree steps. So that is 4 steps per revolution. That is each step is 90-degree. Now in the just now we have seen the coils are switched alternatively. So when the coil 1 is switched on, the rotor is vertical, and when coil 2 is switched on, the rotor is horizontal. But now what happens when we switch on the coil 1 and 2 simultaneously? So here on 1 also there is a south pole, and 2 also there is south pole. Then the rotor will try to align in between them. So in this case we can achieve smaller steps than the first case. So here you please observe how the coils are energized and the rotor is positioning itself. So when individual coil is energized, it will try to align with that coil. But when the two coils are simultaneously energized, it will try to align in between. So here by simultaneously energizing the coils on the stator, we can increase the resolution of the motor. So in the first case and second case, the number of coils are same. Only due to the switching strategy, we have increased its resolution to 8 steps. Now you see it is moving in 45-degree angle, so we can achieve 8 steps. So here when we are going to use a motor like this, we can have a position, we can hold any position which is 0 degree, 45-degree, 90, 135, 180, like that in terms of 45-degree steps. Suppose if you want to achieve better resolution of this, say we want to move it by every 1 degree, then we have to increase the number of coils on the stator. But practically if you want say 360-degree every 1 degree resolution, then we need at least 180 poles, which is not feasible. So in case of practical scenario, the construction of the stepper motor is going to be like this. The stator is a simple magnetic material which is having some teeth, and the rotor will have a particular number of teeth, and the stator coils are placed surrounding that, and the stator will also have construction like teeth. Now what happens is that whenever we try to energize the coil, so the teeth on the rotor and the stator will try to align each other, and thereby achieving the motion of the stator. So here on the rotor, as it is a magnetic material, it will simply attract to the magnetic field, but it will not show any south or north pole. But this type of construction we have seen only for understanding the principle of operation. But practically the stepper motor looks like this. So when the electromagnet is turned on, so and one more thing, like the stator magnets needs to be continuously on and off. So in this case we cannot use permanent magnets on the stator, because we cannot turn on the magnetic field of a permanent magnet. So it has to be an electromagnet. So when the coil is energized, magnetic field is produced, and when it is turned off, the electric field disappears. So here you can see that there is one, the electromagnet 1 is active. So here the teeth try to align. Here there is no difference of which teeth will align with what. So as there is no south or north pole associated with this is a simple magnetic material. So whatever is nearest teeth possible, in that configuration it will try to align. So here the construction is like the number of teeth. Here there will be slight reduction in the number of teeth on the rotor. You can see that when the teeth are aligned with the first coil, in the second one you can see there is a slight misalignment. So that misalignment will judge the resolution of the motor. So now the coil 1 is energized, so all the teeth near to the coil 1 is aligned with the respective teeth. And when coil 1 is turned off and coil 2 is turned on, in the second image you can see that there is a slight rotation which is marked in yellow portion of the rotor to align the teeth along the teeth of the second coil electromagnet. So like this, by changing the activation of the coils on the stator, we can achieve a continuous steps on the stepper motor. So now first the coil 1 is activated, and when the coil 2 is activated we have seen slight rotation, and again coil 3 and again coil 4. Like this we can have continuous steps due to the special construction of these. See, though we have completed one cycle of all 1, 2, 3, 4 electromagnetic activation, but we could only achieve small rotation. So in this way we can increase the resolution of the stepper motor. So the stepper motor resolution, if we use a permanent magnet in place of a rotor, it is not possible, but due to the special construction practically we can achieve very good resolutions for even in terms of 0.5 degree, 1 degree, like that. So here the same is depicted in times of binary input table. So the first one, there are 4 coils A, B, C, D. So these 4 coils are activated simultaneously, 2 of them A, B. Now here in the step 1 it shows 1100. So 11001 is for switching on the coil, and 0 is to indicate the turning of the coil. So 1100 depicts that A and B is on and C and D is off. So here the teeth is going to align in between both A and B. So in the next it is 0. In the next it is 0110, that means B and C is on, so it is going to align between B and C. And the next one, C and D is on, so it is going to align between C and D. And in the next, A and D. So like this we can have a different kind of discrete motions with the stepper motor. So depending on the number of coils, we will have that many wires coming out of the motor. So this is, you can say, one of the disadvantage of the stepper motor. Say now these 4 coils we have to individually control. So there should be 4 wires, and they should be supplied corresponding voltages, on and off signals. So which is 0 is indicating for off, and 1 is indicating on. So like this, a stepper motor driver continuously generates these binary codes to switch on the different coils at different times to have a desired motion of the stepper motor. Suppose now we want to have a clockwise motion, then we have to send codes from the microcontroller like this 0011 1010. So in that case, so the motion is flowing like this: step 1, step 2, step 3, and step 4. So that is clockwise direction. Suppose if you want to reverse the direction of the motion, then we have to send the codes in a reverse manner. So first we will be sending 0101 1100 1010, then 0011 again. So like this again, back to step 4. So now by just changing these steps, by just communicating these steps, we can set the motor in the desired position. So in this way we can achieve discrete motion of the stepper motor. So these are the some of the practical applications where we see them in day-to-day life in some kind of printers where the paper is moved in terms of steps, or a scanning device where the paper or anything needs to be scanned. It has to be scanned from top to bottom. In the scanner head will be moving in terms of steps, scanning each section. Also in case of CNC lathes, where the position needs to maintain in terms of certain steps, or in paper feeds, we can see these servo motors. So this is a practical construction of the servo motor. You can see that there are several teeth on the rotor, and there are the stator coils. Here we can see that there are 4 coils, and so there are 4 wires coming out of the motor. So though there are 4 coils, the number of teeth on the rotor and number of teeth on the stator will determine its resolution. We have seen that by using permanent magnets with 4 coils, we can achieve maximum 45 degree. That means either we can stop the rotor at 0 or 45, not in between any value. But by having this kind of teeth construction, we can achieve greater resolutions. You can also observe the teeth and the inner part of the stator. So whenever the coil is activated, the teeth are going to align to nearest possible configuration. So there it achieves the step motion. So here these advantage and disadvantages are listed. So advantage is that low cost for controlling this kind of motion, that it's a low cost device. Otherwise, if you want to achieve the same motion through normal DC motor, then we need to have a dedicated controller, and too much computational power is required. But here, due to the construction of the motor itself is like that, so we can very easily achieve the step motion. And they are very rugged, simple to their construction is simple, and they can operate in an open loop control system. So the same motion, if you want to achieve through normal DC motor, then we need to apply a closed loop control system, and their maintenance is low, likely to stall or slip, and they can work in wide variety of environments. So the disadvantages include they require a dedicated control circuit, because they always read, they only want these codes as input: 10100101. So the number of that code length is dependent on the number of windings on the stator. So they use more current than DC motor, because they need current to energize the coil and produce a stronger magnetic field, so that the rotor will position with help of the magnetic field. So at low speeds also, due to these stronger magnetic fields, we can achieve a very good torque output. So to just brief today's lecture, we have seen the what is some basic definition, like what is sensor, transducer, actuators, and in actuators we have gone through the construction and working principle fundamentals of DC motor. Then we have seen different types of different classification of DC motor based on the armature winding and field winding. Then we moved on to different strategies to control the speed of DC motors. Then we have briefly discussed about the servo mechanism, servo motors, how we can just communicate a signal to servo motor and achieve the desired position and speed. And later we have seen the stepper motor, how it can move in different steps, how the practical construction of the stepper motor is implemented to have a higher and feasible rotation steps. And finally we have seen the advantage and disadvantages. So in the next section we will be seeing how microcontroller can be used to control these motors and to read sensors. So I will be giving some brief introduction to microcontrollers in the next class. So if you have any doubt, you can please discuss.
Sir, kindly please share the PPT.
Okay. How I can share? By mailing through the
Yes, sir.
same?
The course coordinator Abhijit.
Okay, okay. Okay, I will communicate this PPT.
Okay.
So I did not go any mathematical formulations in today's lecture because
Yes.
I am given only 1 hour for these actuators and 1 hour for microcontroller and data acquisition, signal conditioning, all these. So even if you want to just cover mathematical formulation, it will take at least 5-6 lecture hours. So I just try to give the practical and brief introduction to these actuators today. I hope this will be helpful.
Yes, sir.
So, okay. Anyone is having any doubt? Can you please ask? Okay, I think today's lecture is clear. Nobody is having doubt. So with this, can I just close the meeting?
Yes, sir.
Okay then. Thank you very much. I will be taking again class on next Sunday.
Excuse me, sir.
Yes.
Sir, I suppose the class is over, sir. The students were asking for the PPT that you said that you would be sharing with students.
Yes. I will be. I will be mailing to the
It-
course
To me, sir.
coordinator.
Yes, sir.
Huh?
Yes, sir. To Abhijit, sir. I'll help you with my email ID, sir.
Okay. Okay. So today I have got mail from this, right? PGCSM. So
PGCS.
can I mail to the same?
Yes, sir. Sure, sure. That would be great, sir.
Okay, okay. To this email ID I will mail. So from there you can get.
Okay. Thank
Okay.
you.
Okay. I thank you all for listening to me. Bye bye.
Thank you. Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you, sir.